All right. I don't know how many lesson sets we're going to do of this nature, but this is lesson set 30. It's basically the final exam that we're going to be practicing, and it'll give us about 7, 8 weeks of practice, 6 or 7 maybe. And your grade will be based on how many of these problems you get right. And we'll set some goalposts in a while. And if somebody gets everything right and they're really moving forward and they've got a couple of weeks left in the term, we'll throw another 10 or 20 problems your way. Future work. So I'm not going to spend much time on this. All of these problems are for the most part done in the first 25 lesson sets or 24. So this is really just mechanically to see if you're getting the problems right. So whatever you can't finish in class, you're going to have to finish at home. And we'll have at it in just a second here. As I say, if there's a problem that in the first 70 problems that we do, write in the comments, I'll look at it and say, okay, the next time we do these 70 problems, I'll highlight that problem and probably talk about it some more. Can do that without too much trouble. But otherwise, to keep this manageable in terms of time, I'm not going to talk much. Just going to do the problems out, and then you can see if you got it right or wrong. And if you got it wrong, then definitely let us know, and we'll practice it some more, because everything that we're doing you need for your future classes. Eventually people drop out of math because the foundation isn't there. So let's create that strong foundation, and this is only good for you if you can recall what we're doing. That's why we're doing it so many repetitive times. All right, and maybe after 5 or 10 lesson sets, going to have to mix up these problems, because if you take a calculus class, all these calculations come your way, all these algorithms, all these functions. 1 minute you're working with e to the x, and the next minute you're working with a trig function. So we got to practice that. All right, so let's have at it. Can we see everything? All right, and I'm hoping that in 20 minutes I'm done. We'll find out. I'll move the 25 this side, so that's going to be 10x. I'll move the 11 that side, that's -9, so x equals -9/10. 3 coordinates. I'll do the x's first. I'll start with 6. I'll change by 5. I'll do the y's next, -14. I'll go down 3, -17, -20. I'm not going to check my work at all. You can check and let me know if I make a mistake. Equation of a line. X plus 3 gets rid of -3, and I want a 4 to correlate. From 4 to 2, I'm going down 2. From -3 to 8, I'm going up 11. So there's your equation of a line. 2x, so -2/7 times 2 is -4/7. Do that in your head. -1 is -7/7. I'll use the eraser here. So that's going to equal -4/7, -7/7, -11/7. All right. G of x equals -4/3. Another name for g of x is 2x minus 1. When does that equal 4/3? Well, I got 6x minus 3 equals -4. I got 6x equal to -1, therefore x is equal to -1/6. Let's make sure I did that right. Looks good to me. Mx plus b, so that's going to be -2/9 x. Minus times a minus is plus 10/9. -99/9 is equal to -2/9 x minus 89/9. Got to multiply this out. 2x squared times 3 is 6x squared. 2x squared times minus x is -2x cubed. 8x times 3 is 24x. And 8x times -x is -8x squared. All right, so I got a 6x squared minus an 8x squared, but I'll lead with the larger power. 6x squared minus 8x squared minus 2x squared plus 24x. Hopefully that's correct. As I say, I'm not going to check my work. Cat, mouse. All right, so let's do x minus c plus m. Cat gets a mouse. Perpendicular -2/5. Fact. Can we see all of these things? Yeah, I got to keep track of where I am here. Come on, Renee is ready to roll. Okay. Yep, I don't see anything. I know these lights sometimes can wreak havoc with seeing what's on the board from the camera. All right, write it as a product. I see 11 common. I see x to the 5 common. I see y squared common. Times 5. X5 is fine. I need 5 more y's. I need 4. X's are now 11. Y squared's already there, so I'm done. Inverse. Inverse ln is e to the, so I'm going to get some exponential activity here. I got to get rid of the 17. I got to divide by 4. I got to do e to the, then I got to add 1. That's the inverse of that. I'm going to move the 30 over, minus 30. I'm going to divide by 3, minus 10. I'm going to do plus minus the square root of 10, imaginary. Make sure that I is outside the radical symbol. X squared. Can see that fine. Can't factor this, so I'm going to complete the square. X minus 2 squared minus 4 equals 1. Now I can see 5. Now I can see plus minus the square root of 5. And I can see I'll add 2. Would have liked the 2 in front, but that's okay. X squared plus 4x minus 21 equals 0 means that x plus 7, x minus 3 equals 0. And therefore my answers are negative 7 and positive 3. I'm going to take 4 away. I'm going to divide by negative 5. I'm going to take plus minus the square root, which is 2 over root 5. I don't care if we rationalize the denominator. Computers take care of it now. Minus 2 becomes positive 2. Plug that in for x and you're going to get 0. So I guess we just found the roots. And I'm going to let the old eraser help me out here. I am going to move the 3x to the other side and set it to 0. I'm going to take out what's common. X times 5x minus 3 equals 0. And I'm going to say x could either equal 0 or 3/5. IBM. All right, so I'm just trying to get folks to, I'm not sure I showed that last problem, but you can see it from here. Quadratic formula, it's got to be memorized. I mean, it's used in so many standardized tests and places. I'm sure there are quicker ways to find roots, but you know, it's a little cumbersome at times. But I almost wrote x equals, we're solving for t. So t is equal to minus b. It's starting the same way, isn't it? Plus minus b squared, except it's capitalized, minus 4. So a is I in this case. AI, oh yeah, big topic. M, that's c, and it's all over 2a, in this case 2i. All right, so that's just formulaic, that's all it is. Distance from this point to that point, which is displacement. Crazy joke. So that's what I get if I were to plot this on a coordinate system through those points. And so what is D? We can see it, 25 and 9, so it's the square root of 34. All right. Moving along. Making sure we can see everything. Yeah. All right. So I'm going to find the vertex of this. The minimum, I think, is what the question on the sheet is. So the minimum is the y value here. So I got to replace that y value. First, I got to find the x value minus b over 2a. Positive 40 over 4 is 10. I plug a 10 in, I get minus 400. I cut it in half, minus 200, minus 7. So my minimum was minus 207. I'm writing 1,000 there. Minus 207. That's a comma. That's the minimum. What is it in graphing form? Well, I got the vertex, so I got x minus 10 squared. Oops. Outside the parentheses. Minus 207. And the only thing I'm missing is the a term. Oh, there it is. I'll take it. So there's graphing form. I got the roots right here if I see a is 2, right? So I'm measuring from 10. I got to go plus or minus the square root of 207 to 0 is up 207. And if I multiply by 2, I got to have a division by 2 in my answer. All right, so minus 10, let's put a bracket here. Let's do the binomial squaring and let's add 12 last. So I got x squared minus 10x plus 25. So final answer, minus 10x squared, minus times a minus is a positive 100x. I want to make sure I did that right. Yeah, it looks good. And then I've got minus 250 plus 12 minus 250 minus 238. All right, and I got backup if I'm wrong here. Yeah, so help me out if I make a careless error, because I always do. 49x6 minus 21 gets doubled, so minus 42x3y. Squaring that, 9y squared. Binomial start with a positive square and end with a positive square. So here we have a3 minus b, difference of 2 squares, a3 plus b. Almost a difference of 2 cubes. Well, I suppose I could factor it that way anyway. All you need is the volume of a cube and it doesn't have to be friendly. All right, squared change from here. So this is the vertex. That's the point that it passes through. So I got to start with x minus 5 squared plus 7. From 7 to negative 7 is down 14. The squared change from 5 to 2 is 9. So there's your function, vertex through another point. So I got x minus 9 if I cut that in half, and I got y plus 1 if I cut that in half. So I got a center at 9 and negative 1, and the radius is, square these, 82 minus 1, 81. Radius is 9. I completed the square, I just didn't show it all. The y's cancel, so we find out the point of intersection here. The y's cancel. I hope you're pausing before I do each problem. Or you know, Next time what I should do is go through the whole room, show all the problems I'm going to do and let you pick which ones that you really want to work on. Hopefully you're working on them all. The whole purpose here is so you've got recall. So the y's cancel, which means I get 2x equals 4. So I know they intersect at x equals 2, so I'll plug a 2 back in. Doesn't matter which one. 8 minus a minus 2. So y is minus 2. That's where those lines intersect. Hope we can see all this. I don't like those streaks. Yeah, I don't think, I'm not sure you can see that, so I'll put it here. 200x to the 19, but I'm going to write it as 18 times x. There's 19. And then I got z to the 8. All right, so 200 could have been written as 100 times 2. So that's a perfect square. I can take 10 out. That's a perfect square. I can take x to the 9 out. That's a perfect square. I can take z to the 4 out. I took care of that one, that one, that one. What's left? 2x. Simplify, minus 3i to the 41. Minus 3i squared. And now the magic number that tells me if it's odd or even. 20, even. That means I squared to the 20th is positive 1. So your answer, negative 3i. 8 to the minus 4/3 equals 1/16. Why did I write that? Maybe I did it in my head. I'm sure it's probably this, huh? All right, so 8x. Okay, so doing this, you want the cube root. You want 16, so you got to multiply by 4. 2 times 2 times 2 times 2, and you want it reciprocated. That comes from 2 to the negative 4, and hopefully you can see 8 is 2 to the 3x equals 2 to the negative 4. Hopefully you can see where that comes from. Bingo, bango, bongo's been giving us trouble. All right, so let's bingo, bango, bongo this thing and not have it give us trouble. Bingo, 7 times x minus 3, 7x minus 21. X times 4, 4x. Well, I'm subtracting 4x. I wish I'd put another number here or something over here because our problem has been that, and that is not addressing the problem right now. But I've got x squared minus 3x in the denominator. So 7x minus 4x is 3x minus 21. 3x minus 21. Okay. 25 pi over 3 is pretty close to what? Hope you say. 24 pi over 3. That's 4 revolutions, 8 pi. 2 pi, 2 pi, 2 pi, 2 pi. All right, now on 25 pi over 3, 60-degree angle, pi over 3, 60 degrees. I hope we can see root 3 over 2. All right, got to conjugate. Conjugated 2 plus 3i is 2 minus 3i. 2 minus 3i, so I'm multiplying by 1, doesn't change the size. 4 times 2, 8. 4 times minus 3i, minus 12i. Minus 5i times 2, minus 10i. God, I hope I'm not making careless errors. Minus times a minus. Positive 15i squared. All over. Middle terms cancel, and we get minus 9i squared. Okay, that's going to become 13. And here we have 8 minus 15, so that's minus 7. Minus 12, minus 10, minus 22i. All right, solving an e to the x problem. Can you see? Yep, there's a white streak there, so I'll go here. Take 11 away. 4. divide by 3, 4/3. Inverse of E, ln of 4 over 3. And then I got to add 4, but I'm running out of room, so I'll add it there. The ln of 4/3 plus 4. Okay, just writing a word problem where I said enervation, which is weakness, causing something to become weak. And the enervation doubles, 20 pounds of enervation doubles every 100 years starting in 2025. All right, so we started with 20 pounds. We doubled year T minus 2025 and every 100 years. There you go. So the only way you can get that problem wrong is if you're not looking at your homework at all, which happens and has happened already in this class. All right, 7 over 49 is a seventh, 1/7. And I guess I got to write the 1 because x squared over x to the 5th is x cubed. 14 over 49, 2/7. And I can see 5 into 70, x to the 5, so that's x 65. All right, so that's that. Y-intercept for the sine function. Well, the sine function goes through 0, 0. Just wanted you to remember that. So what's the y-intercept? Y-intercept is 0. Right triangle, 90 degrees, x equals 2, z equals 5. So we're going to draw it in the coordinate system. Positive, positive. So it doesn't have to be, though. Could have been down here. But I said 90 degrees. Okay, so 90 degrees, we got to go here. All right, so x is 2, z is 5. So what is y? 25 minus 4, 21. So it's the square root of 21. 22 over 40, I can divide 2. So that's 11 over 20. I can't reduce that anymore. But I do know that m to the minus 7 is the same as m to the 7 in the numerator. M to the minus 5 can tuck that in the denominator. So my final answer is m squared times 11 over 20. Ah, we got a nice little, okay, can see it. I'm going to move the 4 over, so that's going to become 1. I'm going to divide by 2. That's going to become a half. The inverse of ln is e to the 1/2. E to the 1/2 is the square root of e, by the way. Plus 8 becomes minus 8. There's your answer. I got to do some erasing here. Yeah, I did bring my eraser. How nice. So I'll make some space for it here. All right, so we're looking for positive, 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 or negative, 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 or positive, positive, negative, negative, or negative, negative, positive, positive, greater than 0. But I don't have to do that because I can see that a 2 happens at 10, and I'm not going to get a sign change there. I can see a 2 getting a sign change. I can see negative 2 getting a sign change. All of this has been discussed in earlier lesson sets. I can see a 4 getting a sign change. So all I need to know is whether it's true or false. And then I can make changes or not make changes. So let's put a million in. Million positive, million positive, million positive, million positive. Divide 4 positives, you're bigger than 0. So I know it's now true. No sign change, sign change, no sign change, sorry. No sign change, 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 change. So you can take more time, pick some numbers like 3. It should be false. Let's do that one time. 3, that's a positive, parentheses, 3 minus 10 squared. I lost the square there. That's always going to be positive when I square it, unless it's 10. 3 plus 2 is positive. 3 minus 4 is negative. I wonder what that quotient is. 1 negative. Yeah, it's not bigger than 0. False. You can check the other intervals as well. All right, we got ourselves what I hope is a quick practice that negative 2 times 1 is negative 2. Oh, I guess I got to get a 1 out of this. The only way I can make that happen is to put a 1/6 in there. Okay, you can also divide. There's your 1/6. That's the ln. 1/6 ln of 1, right? 1/6 log base 1/6. Wait a minute here. Oh yeah. Yeah, I shouldn't have even done this, but that's 1, and so that's 1/6 to the 1, and there's our answer, 1/6. Okay, I hope you just put it in the parentheses. All right, let's get rid of that. Yeah, I don't want to get rid of that. Slowed me down. Hypotenuse 23, find the other side. You got a 30, 60, 90. So here's your 30, 60, 90 ratios. There's your 90 degrees. So √3/2, 1/2, and 1. Those are your ratios. I can make that triangle smaller, but if I keep the angles at 30, 60, 90, the ratios stay the same. That's one of the most important things to learn about trig. Right, so I'm going to multiply this by 23. It's 23 times bigger. I'm going to multiply that by 23. It's 23 times bigger. I'm going to multiply this by 23. It's 23 times bigger, and you're probably going to see that on your SATs. So this one over here is 23/2. Clean it up a little bit. And if I gave you that one, and you wanted this one, I hope you would multiply 23/2, that side, by √3. There's your √3/2, 23 times bigger. All right, so that becomes hopefully a 5-second question with practice. 10-second question with practice. 5m + 2 times 25m squared minus 10m + 4. Boom, done. Quick Algebra 1 review here. A lot of these are Algebra 1 review. So take out a 5, factoring. 5 times x squared minus 6x plus 9. I see a perfect square right there. I'm seeing x plus 3, minus 3, excuse me, squared. All right, let's erase as we go. That way I don't have to erase when I'm done. All right, nasty problem, tiresome problem. Minus times a minus, minus 9. X squared times x squared, x to the 4th. And we see what I'm doing over here. Yeah, barely. Minus 3 times minus 2 is positive 6. 2 and 1 make 3. Minus 3 times minus 1 is positive 3x squared. Now we got to do minus 2 times minus 2 is minus 4x to the 4th. I'm going to put them in columns. Minus 2 times minus 4 is 8x cubed. Minus 2x times 10x is minus 20x squared. Now I've got like terms in the columns. Minus 13x to the 4th plus 14x to the 3rd minus 17x squared. Hopefully I was careful. When am I ever careful? Oh, God. Math teacher that's not careful. All right, I'm going to flip this. 8/27, so I'm doing that operation. Now I'm going to take the cube root, which is 2/3. Now I'm going to square it. Final answer is 4/9. Taking cube root here. Let's get rid of this as we go. Nice clean board here. Just for a moment, catch my breath. All right, so I'm seeing the cube root of 8 times 4 for that. I'm seeing x to the 30 times x. Any multiple of 3 is a perfect cube. Y to the 20 becomes y to the 18 times y squared, and z to the 6 is a multiple of 3. Final answer, cube root of 8, 2. Cube root of x to the 30th, x to the 10. Cube root of y to the 18th, y to the 6th. Cube root of z to the 6th, z squared. Times the cube root, don't forget the 3. I need a 4. I need an x. I need y squared. Okay, so that one's done. Here's the next one. Remember, you pause the video. I'm just going to keep going. So that's done. So I'm going to write 10√3 times √15. √3, √5. There's √15. I got to do this. 10√3 minus root times √3, √5 minus 10√3 again times 4√3 with a, I already got the minus, times 4√3. Okay, and the last one is plus 10√3, and I'm going to write √6 as 3 root 2. So I'm using the factors here because I know root 3 times root 3 is 3. So this becomes 30 root 5. There's another 3 times 4, 12 times 10 minus 120. I can't put those together. This is the square root of 1. I don't have the same radicals. Okay, so they're not like terms. There's another root 3 times root 3, so 30 root 2. Yeah, I can't put those numbers together. Think of this as x and that as y. All right, so that's done. Let me erase that. Getting there, erase that. Okay. Which one we on? 51. 28 pi over 3. Can you see it? Yep. Well, that's pretty close to 27 pi over 3. And that's 9 pi. 9 pi is right there. I'm one less. No, I'm one more. 28 pi over 3, one more. I almost got careless as I get towards the end of these videos. I usually do. So that's going to be cosine, so negative 1/2. We're looking for that width. So that one is negative 1/2. ln of 9/4. I'll give you the exact answer and then we'll go after it. I guess I can erase this one now. All right, so that's going to be 2 ln of 3. So the exact answer is 2 ln of 3 minus 2 ln of 2. There's your exact answer. All right, now 9/4. 9 could have been written as 3 squared, 4 as 2 squared. 3 changed to e notation is approximately e to the 1.1 to the 2 over e to the 0.7 to the 2. Now, what are you doing when you look for ln? You're looking for exponential activity. I see 2 times 1.1. Oh, I see it here as well. 2 times ln of 3, 1.1. And I think I'm subtracting. Yes, I know that's a subtraction of exponents. And I'm doubling 0.7, doubling 0.7. So there's your exact answer. And your approximation is 2.2 minus 1.4, which is 0.8, I believe. There's your approximation. All right, tangent of pi over 6. Pi over 6 is a 30, oops. EA equals PE to the RT. Okay. Compound interest. 6%, we're going to double $1,000. How long does it take? Well, that's going to be the ln of 2 over 0.06. ln of 2 is 0.7 over 0.06 is equal to 70 over 6 if I multiply both by 100. And that's 11 4/6 or 11 2/3 years. Now I'll take more time with it because we haven't done a lot of these. Okay, so I am going to double $1,000. So I start with the principal. That's what P stands for, $1,000. And I am going to compound the, and I've got an interest rate of 0.06 T. All right, so what's the first thing we're going to do? Divide by 1,000. Well, there's your doubling. E to the 0.06 T. And I think I want e to the 0.7 to double. I'm going to double something. I think I want e to the 0.7. So what does that imply? That implies that 0.06 T has to equal the ln of 2. Right? Because I got to undo e here. Inverse operation. And that means I'm dividing ln of 2 by 0.06. I think if I wanted to triple it, that might have been ln of 3. And I think if my interest rate went down to 5%, then I think I'd be dividing by 0.05. Seems like there's a real shortcut to that. Yep. All right. Did I do this one? I don't even remember. I don't think I did. All right. So we're going to subtract 7. That's 1. We're going to divide by 16. That's 1 over 16. 1/2 raised to the becomes log base 1/2 of 1/16, which I hope you can see is 4. 1/2 times 1/2 times 1/2 times 1/2. Then I'm going to multiply it by 4. And then I'm going to add 3. Looks like 19 is your answer. All right, so I got 53 done, 52 done, 50 done. Take some time to erase. Tangent of 5 pi over 6. So 5 pi over 6 is 150 degrees. I got a half. I got negative root 3 over 2, and I got 1 as my ratios in the second quadrant. And remember that's breaking it up into 6 parts, right? You've done enough of those that I hope that you're at this stage of the game just drawing that. Now, I could divide by fractions, or I could get rid of the fraction by dividing by multiplying by 2, by making this twice the size. It doesn't change the angle. So that becomes what? 1, that becomes 2, that becomes negative root 3. So what's my opposite over adjacent? Negative 1 over root 3. You should put the negative in the numerator. Okay. So I did 56. Did I do this one? I don't think I did that one. All right, so we're out of order here. Yeah, a lot of out of order things, a lot of cases going to trial these days. So 1/3 ln of 8, the ln of 2, but how do you see that? Okay, the ln of 8 is 2 to the 3. We said that multiplication by 1/3 is going to happen right here when I put that there. Hopefully you can see why. Power to power is a multiplication. So that's the ln of 2. E to the ln of 7. Well, what's e to the ln of 2? That's 2, right? Because that's e to the 0.7. So these are inverse operations. So I'm just adding 7. And there's your answer. Approximately 7.7. Okay, domain. You got to look at the critical numbers. I can see 5 jumping off the board at me. But I also see a division. And I cannot divide by 0. So the question is, when is this 0? When the parentheses 1. So those are the critical numbers, 5 and 6. Can I use 5? Can I do log, base, whatever? I don't know if this had a base to it or not. If it's not written, then it's understood to be base 10. So 10 to the what gets me 0. And that answer is not forthcoming. So my x's have to be bigger than 5. 6, can I use a 6? Oh, 6 minus 5 is 1. What do you put on top of a 10 to get a 1? 0. Can I divide by 0? No. So what are my answers? X is greater than 5, comma, x cannot equal 6. If you want to use interval notation, 5 to 6, union 6 to infinity. You take your pick, I'll take either answer. Moving right along. I feel like saying now for something completely different, and shout out to Monty Python. All right, so the average rate of change from -2 to 2. Well, let's just go to the table. -2 cubed is -8. 2 cubed is +8. So what I'm finding here is I'm finding from here to here, I'm finding that average rate of change. So that's going up 16. That's going up 4. So this is a 4-to-1 rate of change from that location to that location. Cosine is width. When is width squared equal to 1? When the widths are equal to plus or minus 1. Where's that on the circle? Over here and over here. 0, pi, and I don't care if you repeat 2 pi. Right, with the parentheses here, you don't have to. If you do, it's no problem. All right, and I've been doing something to this the square for a while. I'm going to do another one. I'm going to add another layer of area. Yeah, I just added another layer of area. Seems like my area is accumulating. Gonna look at that over the next month or so and figure out how to symbolically write what I'm doing. All right, let's see what we got. We've got to move Renee here. We got to move this whiteboard here so we can tackle the last. No, I think I want that right where it is because there's 70 problems. So let's bring Renee this way. Let's get that centered and keep going here. All right, I see the difference of 2 cubes, so let's factor it. 3x is the cube root of that. 4y squared is the cube root of that. I'm subtracting. I'll build up the rest of it here. Oh, I didn't leave myself much room. So 3x minus 4y squared there, that's a little better. Square the first gets us 9x cubed. Good, that gets us that. Plus minus is going to get rid of 4 terms here. And so I'm going to get rid of 12. I'm going to do 12xy squared. And then I'm going to square that. 16y to the 4th. All right, so that's the factored form for the difference of 2 cubes. Okay, get rid of that. You have new technology here that allows you to go backwards and forwards on these videos. Push pause. Man, I'm learning here. All right, so let's get a quick graph. So that's going up like that. 2x minus 3 is like that. So we're only going to get one answer here. And we're going to get whatever the bigger one is. So I'm going to square this. I'm going to binomial square that and hopefully correctly. 4x squared minus 12x plus 9. I'm going to set it to 0. So I got 4x squared minus 15x plus 9. Do I see a perfect cube? No. Perfect square? No. But I can see 3 times 4 is 12 gets me close to 15. So I'm going to go with 4x. I'm going to go with x. I'm going to put the 3 there, and I need a minus to get close. I need another minus 3. Oh, and that does multiply out. So our answer to this problem is only x equals 3. Okay, some more space. The final frontier. The limit as x goes to infinity. As we go to infinity, I don't think we care about numbers like 7 or 9. If we go out there in a spaceship and go billions and billions of miles, I don't think another 9 or 6 miles is going to matter. And I don't even think these are going to matter. What's going to matter is the squaring, because when you square a billion, I think you get 18 zeros. Whereas if you multiply a billion by 5 or 10, you get 9 zeros, something like that. All right, so 2x squared divided by x squared is 2, and that was your answer to this problem. You put big numbers into that, you would have come out with a ratio of 2 to 1. Okay, so our rules of logarithms are firmly in place now, having done lesson set 25 to 29. So we know we can multiply those and get x squared minus x. And we know exponentiation can move to the other side. 2 to the can go to the other side. So we get 2 to the 1. Looks like I can subtract 2 and set it to 0. And I got x minus 2 times x plus 1 equals 0. We'll discount the negative because parentheses has to be positive. So it looks like 2 is our answer. What do you put on top of a 2 to get a 2? 1. 2 minus 1 is 1. What do you put on top of a 2 to get a 2? 0. 1 plus 0 is 1. Checks. I wasn't checking before, but I checked that one because I'm getting late in the video. When I get late in the video, I get careless. So we're going to set this as a piecewise function. So I could have written this as B shape up. So the left side is down, the right side is up. What makes a 0? 2. That's where it hinges at x equals 2. So Alfred Hitchcock, boom, boom. You can look at some of his old TV shows and you'll see that pop up on the screen. Okay, so I'm going down. So that's a minus 3 parentheses 2x minus 4 plus 1. And that happens when x is less than 2. And if you want to take the shortcut, the multiplier is 6. And it's going through 2, 1. You could have written that in place of that if you wanted to, with a negative, of course. This one is positive 3, 2x minus 4 plus 1, comma, x greater than or equal to 2. And I don't care which ones you write, because what I'm really testing here is down, up, the 2 branches. Are they in the right place? Now we're going to set this thing to 49. We're going to solve. You could use to in previous classes, set this to 49 so that we got some practice using the piecewise function. But we'll just solve this for 49 right here, right now. So I'm going to subtract 1, that's 48. Divide by 3, that's 16. I'm going to look at, it hinges at 2, so I plus or minus 16, but I've still got more inside here. I got a little bit of an effigy of x going on. So I've got 2x minus 4 equals positive 16. And we also have 2x minus 4 equal negative 16. So if I add 4, I have 20. If I divide by 2, I have 8. 16 minus 4, 12, 48, 12, 30. Did I make a mistake? 16 minus 4, 12, 36 plus 1. 2x minus 4, 1, 48. Divided by 3 is 16. 16 plus 4 is 20. Oh, is 20. 20 divided by 2 is 10. Yeah, I knew I'd get to the end of the video and start to have trouble. 20 minus 4 is 16. 48, 149. There we go. And that's 8. That's 16. Just solve the problem, Jim. So add 4, negative 12. divide by 2, -6. Okay? Yeah, 2 times -6, -12 minus 4, -16, the absolute value, +16. Just got to start checking a little bit because I'm getting winded. All right, so we have two critical numbers. What are they? -6 and 10. And these are linear branches. Well, that's good. -6, 10. There we go, getting careless. Again, if I do true or false, because they have linear branches, it's going to alternate. So just pick a number bigger than 10. Let's put 1,000,000 in here and see if I'm greater than 49. Yes, I am. So it's true, false, true. Okay, so your answer, -infinity to -6, union 10 to infinity. I'm sure there's another different perspectives on all these problems. Maybe we'll solve them from a different perspective the next time. All right, let's spin this around. There we go. Yeah. Okay, put that in factored form. I see a square, I see a square. So I'm looking at 2a plus 5 immediately. Checking. 2 times 5 is 10. Doubled is 20. I'm done. All right. If the vertex is on the y-axis, then it's one of these x minus 0 squared, right? Which means I can just go to x squared. And x squared has been what? Flipped and raised by 12. So x squared plus 12 is the quadratic. 3, 3, -4, -4 means I'm finding the intersection of y equals x. Y equals x minus x squared plus 12. And you need to know how to find those values in a calculus class so you can study the area between those two curves. All right, so sine squared equals 1. In the unit circle, sine is height. So we're really looking at x squared equals 1, but you got to remember what x stands for. An angle. So when does h equal plus or minus 1? We've been doing that a lot. Pi over 2, -pi over 2, or 3 pi over 2, sorry, because we're going to look at 1 revolution. Go check. Last problem. No, 68, 69 was, oh, I did them out of order again. All right, so it is the last problem. Yay. All right, and I'm trying to find the inverse evaluated at 4. 4 is the output of this equation. It's the output. So we're going to find the input right here. We're going to find what I plug in here to get that output. So I got to move the 2 over. So that's 16. 2 to the 4 is 16. I got to add 5, 21. So if I put 21 in here, I get 16. What do you put on top of the 2 to get a 16? A 4. And if I put 4 in here into the inverse, well, I never did find the inverse. I will find the inverse for you because I just talked about it. So let's get rid of that. So what's the inverse of log base 2? 2 to the x. What's the inverse of subtraction of 5? Addition of 5. Now if you put 4 in, you get 21. Okay. All right, that's that. 70 problems. That speed, I probably made addition, subtraction errors places, but hopefully not too many. But I'm trying to keep the timetable here manageable. All right, and I got turmoil over back in back home country, huh? Sorry to hear about that. Personal message out to Yasser. So let's hope that things don't get any worse. All right. End meeting for all. Stay safe, stay warm.